Okay, you're right. Welcome back to another video. We're continuing with our series on linear relationships, that is, patterns that create straight lines on a graph. We're going to be looking at examples of that today. So we're going to be going from a pattern to finding a rule, which would dictate future components of that pattern. And then we're going to learn how we can then graph that on a number plane. Okay, so here we have a pattern which is made up of matches. So there's a number of sort of instances in this pattern, and each time we're increasing the amount of matches that is in each instance. Okay, so the first thing that we're going to be doing is we're going to be sort of seeing, well, how many matches are in each instance in this pattern. We're going to be thinking about, well, can we detect some kind of pattern in the way that the number of matches is increasing? We're going to see how can we describe that algebraically to create an equation. Okay, and that's the really powerful thing. If we can turn a pattern into an equation, we can apply all sorts of maths to it, including drawing a graph of it. Okay, so that's what we're going to be doing in this lesson. So let's consider this first part of the question here. We're completing a table. Now you can see the number of triangles is at the top of that table, and the number of matches is the bottom bit here. So for the first instance in this pattern, we've got one triangle, which is made up of simply just 3 matches. Okay. Now in the second one, we've got 2 triangles here, but the second one shares a match with the first one. So we're actually only adding 2 extra matches. So we have 5 matches in total. And you can see for this next one, again, we're adding in only just 2 more matches. So we get 7 in total. We add in 2 more matches, 9 in total, and 2 more matches, 11. Okay, let's just check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 matches in that last instance. Okay, so now we can look at these numbers and we're going to try and see, is there a pattern here, and can we describe that pattern with words first? So how can we describe this pattern? Well, for the first one, it looks like there's 3 times as many matches as triangles. But then for the second one, it doesn't quite work out because 2 times 3 doesn't equal 5. And likewise, 3 times 3 definitely doesn't equal 7. So we've got to think of a different kind of thing that's happening. Well, each time the number of matches is increasing by 2. Okay, but also the starting one is twice this the number of triangles plus 1. So it's increasing by 2. We're doubling each time here, but we're going up by 1 here. So it seems the amount that the number of matches is increasing is twice as much as the number of triangles is increasing. But there's also some kind of difference. We've got to add 1 as well. So I'm going to say the number of matches is twice the number of triangles plus 1. Okay, so we can find the number of matches. If we double the number of triangles and add 1, we should get the number of matches in each of these instances. Okay, so we're going to use using x to represent the number of triangles and y to represent the number of matches. Write a set of points describing this information. So what we're going to do is what does it mean by write a set of points? Okay, what it means is we're going to create an equation which describes this pattern that we've just written in words. So for part C, so if y is the number of matches, okay, now the number of matches is the number of triangles times by 2 and added 1. So the number of matches equals the number of triangles times by 2, or 2 times the number of triangles plus 1. And now we have an equation which describes this pattern that we've had here. Okay, we're just using algebra to represent the matches, and the triangles as such. Okay, so we're going to need another number plane. Now, in this instance, we're just looking at positive numbers. So I'm going to do a graph that just contains the positive parts of x and y. So it doesn't have the negative aspects, just the positive ones for this graph here. So this is my x, this is my y. Okay, so x is the represent the number of triangles. So let's 1, 2, 3, 4, 5. We'll just put those numbers in for now. And then the number of matches is our y value. Let's try and keep it the same roughly space as we did for x. 2, 3, 4, 5. Now this goes up to a bigger number, 6, 7, 8, 9, 10. Okay, so let's just start with this, and we're going to plot these points that we have in our table onto our graph, kind of like we did yesterday, except instead of writing letters and the coordinates, we're just going to put little x's to show that point on the graph. So number of triangles is 1, and then the number of matches is 3. So there's our first point. Number of triangles is 2, number of matches is 5. Number of triangles is 3, 7, 4, 9, 5, 11. And you can see here, we're starting to get a straight line. Now, my scale isn't exactly perfect. On your grid book, you'll be able to do it much more accurately. But you should be getting this kind of straight line forming between these points. It's because it is a linear relationship, which means it makes a line. Okay, so we've graphed these points on the number plane, and we want to mark the next 2 points and write their coordinates. Okay, so what we want to do is we want to think, well, what's 6 going to be? Oops. What's triangle 6? I'm going to move that across a little bit, give a bit more space. Now, if we continue with this trend, we're adding 2 each time, then the next one is going to be 6, 13. Remember, we always write the x one first, and then the one here, and then above that for number 7. Sorry, it should be a bit higher. It's going to be 7, and it's going to go up by another 2, 15 here. So by using our, and this is going to be roughly a straight line. It should be a straight line there. It's not very accurate. You know what I'm going to do? I'm not happy with how I've done these last 2 points. So I'm going to replace them up. I want to keep this to scale, roughly. Okay, it's going to be a bit higher up, and like that. And that point, again, 6, 13, 7, 15. Okay, so we get this line going through here. Now, we don't have to draw that line in. We're not asked to do that, but you can see here we've sort of made a pattern that creates this line, and that's what linear relationships is all about. Okay, so that's part E there as well on our graph. So what we need to be able to do is find this rule from the table of values. That's the tricky thing. So good luck with the questions today. Do let me know if you have any questions, any more questions, and I'll see you in the next video.